So what I'd like to do in this video is to go through the proof for why repeating decimals change to fractions with nines as the denominator. Sometimes students will wonder why, if you take something like 0.4 repeating, that you get the fraction 4/9. Or if you take the fraction point, or the decimal 0.123 repeating, we said 0.123 repeats, then that's going to be 123 over 999, which simplifies to something smaller. But for now, the idea is, why do these always end up with nines on the bottom? So the mathematical or algebraic way of proving this has been done for a long time. If I take the 0.4 repeating, so we assume that this is going to be 0.4 forever, just keeps going as 0.4s, and I call that my x. I'm just going to say that's x. If I take 10 times that amount, in other words, if I multiply 0.4 repeating times 10, then I'll get 4.4, and then those 4s will just keep repeating just like they did up there. So this is 0.4 repeating. This is 10 times as much, so 4.4, and that repeats forever. Now if I subtract these two from each other, so in other words, I take 10x minus 1x. 10 minus 1 is 9x. So now I have 9x. And if I take 4.4 repeating minus 0.4 repeating, in other words, I'm going to subtract away all these 0.4s forever. And the only thing that's going to be left is the 4. And so what that does for me now is I've eliminated all of the repeating numbers by subtracting them away, because I can subtract all these numbers away infinitely. And what I'm left with is that 9 times x equals 4. So if I divide both sides by 9, 9 divided by 9 is 1, 1x equals the fraction 4/9. And there you get the solution, 4/9. And that's true no matter how many numbers repeat. It just changes how many numbers I'm going to, or how many nines I'm going to have. So I do the same thing with this one here. If I have 0.123, 1, 2, 3, 1, it just keeps going on forever. And I call that x. And I say, well, let's see, 3 numbers repeat, so I'm going to multiply it by, this is tenths, hundredths, thousandths. I'm in the thousands place before it starts over again, so I'm going to multiply it times 1,000. So 1,000x will give me 123 point 123, 123, 123 forever. So that just keeps going on. And so if I subtract, 1000x minus 1x is 999x. And then if I subtract on this side too, whatever I do to one side, I'm doing to the other. So this is really minus. All of this is just going to go away, and the only thing left is the 1, 2, 3. And so then if I divide both sides by 999, 999 divided by 999 is 1x equals 1, 2, 3 over 999. And this always works with repeating decimals. It's a way of showing that they are rational numbers, because they can be written as a ratio, a fraction. Even though they repeat and go on and on forever, they can be written very clearly as fractions like this. So that's why repeating decimal numbers always end up with nines on the bottom. And you can tell how many nines you need by how many numbers repeat generally. Some cases where you have some numbers that start out and you need a few more nines, but the number of nines is determined by how many numbers you have to go before the decimal repeats itself. So that's a kind of a short explanation of where the idea, or where repeating decimals always end up having nines as their denominator. And again, some of them simplify, so you end up without a 9 on the bottom. In some cases, for instance, 0.3 repeating is 3/9, but that reduces to 1/3. So sometimes they end up without the 9 on the bottom because they reduce. And that again is kind of an idea of why you end up with 9s on repeating decimals.